So yeah, that really sucks. But getting around some user friendliness, specifically on macOS, you've got AppleScript, and AppleScript is sort of a programming language, but it looks more like English than a programming language. If you can see the code here, basically this is something I've used to fuzz Internet Explorer on macOS, and basically what you do is you tell application Internet Explorer, and then basically have a while loop in there, and then open a Gopher URL. And this is pretty cool because in Internet Explorer, you don't have refresh when you're doing Gopher. You've got refresh in HTML, you've got no refresh in Gopher. And you could hit the refresh button a million times, but your fingers start hurting, or maybe they might even start to bleed, I don't know. But if you've got AppleScript, you don't need those things. AppleScript will do that for you. You'll tell AppleScript, do that what I would usually do, and it'll just do it. And besides the fact that you'll save a lot of pain in your fingers, it'll be faster because refreshing, you got human interaction, but this is just automated. So AppleScript's a godsend if you're going to fuzz stuff on macOS, but at the same time, it can cause problems because some applications on macOS they either don't implement AppleScript and then you can't use it, or they've implemented really, really badly, so badly that when you try to write some AppleScript code, the thing will just crash when you're trying to communicate it with it. So, but besides that, AppleScript's really, really cool. Right. Determining how stuff fails, because I mean, it might sound a bit obvious, but sometimes it's kind of nice to have some pointers towards how these kind of things fail. Obviously, crashes, usually those are pretty easy to detect. But and I'll talk about that a little bit later, and very small snippet on the next slide. Huge memory consumptions, they can usually be found with default tools, and I have a slide about that as well. Reboots, yes, I mean, usually you notice a reboot, so. Same thing with hangs, you can usually notice them. But yeah, that kind of depends what kind of hang, and because sometimes, sometimes you feel hangs, but sometimes you just don't. I mean, if you're not looking at the application specifically, you might not feel it in your operating system. It depends on the bug. Right. So crashes, yeah. I mean, this is kind of obvious, but it looks cool though, doesn't it? Right. So Core attached debugger, and I'll be talking about debuggers quickly in a couple of slides. So that's basically, it crashed, and in this case, it's pretty easy to determine what's going on. Huge memory consumptions. This is from a real case, by the way. I was doing some fuzzing on Internet Explorer, and I made some bitmap fuzzing tools. And at some point, I came across some bitmap, and my mouse was hardly moving, and things were going very, very badly, and there was a huge load. So I hit Alt Control Delete, and I go to Performance, and usually, you see the page file usage history, and basically all my physical memory just was gone. Internet Explorer had just eaten all of it. So, and it's easy to see it here, and then at the the after picture, after Internet Explorer has died, after I've killed it, you see all the performance, it's all coming back. So it's kind of nice to see it in the graphical way. But usually it's easy to detect these kind of things. Yeah, a reboot. A while ago, I was fortunate enough to be at a friend's place who had a Cisco, and I figured, I've never fuzzed a Cisco before, so let's do that. And this was the result I got. I haven't played with it before because I know very little about Cisco devices, but it was fun though to see it break. And then you get some stuff in there, some registers, and then Cisco realizes it has crashed and it reboots. So it's kind of neat to see those kind of things. But hangs is, it's another Internet Explorer thing. Basically, if your CPU memory usage for some application never drops until you kill it, something's up. Right. So, seeing more than just a crash. This is just a couple of pointers. I really don't have time to go into detail on any of these things, but if you're interested in some of these things, you should stick around for next talk by Richard. He'll be giving you a really cool tour of some of the things in IDA Pro, which I mentioned here, and how you can figure out some structures of binaries and how you can use those for fuzzing, for example. If you're fuzzing something, try to attach a debugger. You've seen GDB, but the thing about GDB is that it's not really that wonderful. I mean, it's nice if you have your code compiled with debug and all these kind of things, and you've sprinkled some printfs around and things like that. But if you're gonna fuzz things that will create threads and that will fork and that will call the execute system call, GDB is kind of bad because GDB can't handle threads that well. It basically breaks on a lot of thread stuff. Execute system call is just as bad. Fork kind of depends. If you're lucky, it doesn't. It does work. If you're not lucky, it doesn't. Auto debug is one of the Windows debuggers. It's pretty neat. I've looked at some of that stuff. Pretty cool. WinDBG is sort of like AutoDBG, but it's made by Microsoft. Softice is kind of like one of the huge debuggers in Windows. It's a kernel debugger, and if something breaks, you can get it to pop up. So this is just some of the debugs that you might want to look at. These assemblers can also be helpful if you fuzz something and you've got an idea where it's gone wrong, but you don't know exactly what's gone wrong. You can fire up your disassembler and look at the entire program or large parts of the program. IDA Pro is obviously, I mean, this one's kind of unfair because like IDA Pro is like the disassembler. There's not a single one that's better probably than IDA Pro. And Object Dump as well. It doesn't really compare to IDA. Object Dump is a really, really simple tool. Sometimes Object Dump is useful. Usually it's not that useful though. IDA Pro is amazingly cool. You guys should, if you want to know some more about IDA, you should definitely stick around and see Richard's talk. Right. Yeah. The thing is that you should, when you're debugging stuff, try to keep track of everything that's forked and spawns that have been threads that have been spawned. Excuse me. If you're using GDB, you're kind of out of luck because GDB will probably crash on some thread stuff. Right. Some more utilities. For Unix, you've got strace and ltrace. strace will give you some nice information for system calls that we used, and ltrace does pretty much a similar thing, but for system calls. And on Windows, you've got a tool that FX developed, which is Dumbug, and it can do similar things. The other thing for seeing more than just a crash is looking at your log files. If you see something like that in your log files, something's up. Somebody tried some kind of format string bug, and apparently they succeeded, at least in triggering it. Right. Okay. Extending existing fuzzers. That's one of the things that you should definitely do, because the thing with, for example, the Mangle.me tool from Mikhail Zalewski is that it was just scratching the surface. It only fuzzed a small part of HTML, and it didn't even cover anything else that the browser did. So if you just take any fuzzer that anybody ever made, you just take it and look what it does, and then think about things they've forgotten. If you implement those, and then just run your tool against whatever they ran it before and all the bugs they fixed, just run it again, and I can almost guarantee you that you'll find new things. You don't always have to start from scratch. Just take other people's work, build upon it, and usually you find new things. Another example of this is, and this is actually a good one, is the Protos. The SIP fuzzing tool they had is, I mean, they've spent months trying to figure out exactly where things can go wrong, and they've worked things out in detail, and so they've covered a lot of code paths in a lot of devices or software that parses SIP, and so they've probably, if you run something against Protos, you can catch most of them. But then a couple of months ago, somebody discovered a bug in Ethereal in SIP parsing. And this was one of the main attributes of zip. And the actual bug in Ethereal was a trivial string copy where you had a stack smash and buffer overflow 101. But the thing is, because the guys from Protoss had run their tool against Ethereal, and they discovered several bugs in the zip parsing, but they had missed a specific one. So if you had taken the RFCs and look at the way people implement stuff, and you would have extended Protoss for this thing, you would have been able to find that particular bug in Ethereal. So even if people have put a lot of thought into developing fuzzers, even if they've spent months developing a fuzzer and putting a lot of hours into that, they'll still have missed some things that you might think about. Just implement it, run the tools again. Usually you find cool stuff, right? So my conclusion, because I know you're all bored of me and you want to go out, but my conclusion is that fuzzing is amazingly cool. And even if I sound boring to you, you should still go out and try some fuzzers, because it's like you have to experience, you just have to experience fuzzing and see what it's all about and get this warm, fuzzy feeling the first time you break something. But so fuzzing is amazingly cool. Also, if you compare the amount of stuff that you can find with fuzzing in a time frame, and then see how much time it would take you to do a code audit and come to the same conclusions, it'll probably be like a factor of 10 or something. I'm not saying that you should get rid of code audits and only do fuzzing, because there are some tools some bugs that are hard or or pretty much impossible to fuzz that you might be able to find with code audit. But if you're just out to find a couple of bugs, fuzzing will save you a lot of time. I mean, I spent the last about 2 years doing an unhealthy amount of code auditing, and then I discovered fuzzing. It was like a whole new world opened for me. So you can find a lot of cool things in a short period of time with fuzzing, where it would otherwise take you days or weeks or months or even years when doing code audits. And fuzzing is probably the most widely used method of finding bugs these days. And of course, the final conclusion, the coolest one, is that people cannot write decent parsing code. Right, and this is, okay, so some advertisement. There's a magazine called MISC, and there have been some of these around. I think there have been, the guys from MISC bought like 600 of them with them here. And it's a magazine about computer security. And it started off in France, and in France I think they're up to issue 22 or 23. And since a couple of months they've got MISC magazine here in Germany. And issue 3 contains an article about fuzzing, which a friend of mine made, and he's covered some of my things. So you should definitely check out MISC, it's really cool. Although I don't know exactly what's in it because I don't read German. But I've talked to some of the editors, and they've told me that it's a really cool tool. Magazine, yes, okay. Right, so some interesting links, and this is basically where I'll shut up then. The first one's Violating Assumptions with Fuzzing, which is a paper written by 2 people at Microsoft, Michael Howard and another guy whose name I've forgotten. And basically this is their experience that they've had throughout a couple of years at Microsoft doing fuzzing, and some of the things that they've noticed doing fuzzing. And there's a lot of cool stuff in there. If you get your hands on that paper, if you're at a university, you can get it for free. If you're not at a university, you have to pay IEEE 20 euros to get 5 pages of text. So, or if you're smart, you'll just bounce from some university and get it for free anyway. I wasn't that smart. I actually paid them $20 because I didn't know I could bounce off universities. But so if you're smart, you're not at a university, just bounce over some and just get it for free. But that paper's pretty neat. The next one's basically the talk that Dave Vitale gave at Black Hat in 2002 about Spike. You should definitely look at it. If you're interested in Spike, those slides are a good starting point. The next one is slides from a presentation that FX made, which I really, really like. And basically, at least from what I understood, that the slides or the talk was meant to show people that hacking is really hard work. Although it's really fun, it's a lot of work. And it covers more than just fuzzing. It covers fuzzing, adding statistical analysis and doing binary analysis. And then it also covers the exploit development and the making exploits reliable, and then something like don't use C because C takes too long to develop stuff in. But that one's really cool. It gives